Okay, welcome back to the AEC Hive podcast, where we're talking about innovation in architecture, engineering, and construction. I'm Ralph Montague, director at ArcDocs and co-founder of the AEC Hive, joined by my fellow co-founder, John Egan. John, do you want to quickly introduce yourself?
Hi everyone, it's John Egan, CEO of BIM Launcher. Delighted to be here with an old friend, Keough, for another rundown on innovation and construction.
So we're really excited. We're in LA this week, and to have Keough, who is the CEO and founder of Hypar, and also well known as the father of Dynamo, to be joining us to talk about innovation in AEC. You're very welcome, Ian. Do you want to give us a little introduction to yourself, where you've come from, and a little bit about Hypar, and we can get the conversation going?
Yeah, of course. I'd like to start by saying I love to hear Irish people pronounce my last name.
It's the proper way. It is an Irish second name, right?
It is indeed. I'm obviously far removed from Ireland, but to hear the Irish pronunciation is wonderful. Hi, great to be here. Thank you guys so much for having me. My background. Let's see. Well, I started a long time ago. I started as an artist. I studied sculpture and then moved to New York City with, stars in my eyes and dreams to be a sculptor, and very quickly, started working in fabrication for architects and artists in New York City, and, working in a fabrication studio, learning how to build kind of anything. And then very quickly decided that I wanted to make the transition to architecture. So I got a graduate degree from in architecture from Parsons in New York City, and then immediately went after graduate school and started working at Bureau Happold Consulting Engineers. Because throughout this thing, and throughout my history, I just kind of made these jumps when I decided I wanted to go in a slightly different direction. So I kind of figured during graduate school I didn't want to go and work in a typical architecture job. I was much more interested in the way that buildings went together. And Bureau Happold at the time, and still, were doing some of the most amazing projects I'd ever seen all around the world. And so I joined the office in New York City, which at the time was very small. It's now very large. And we worked on amazing projects kind of all over the world. And that's actually where I cut my teeth writing software, because the big problem that the engineers had in that office was they had analysis tools that were doing analysis. They had modeling tools. Rhino was just kind of coming on the scene. Revit had just come on the scene. So the first day I showed up was the first day we started working with Revit in that office. And they had to get information from this package to that package and everything else. So a lot of my early software was just writing tools to help the engineers, structural, mechanical, get data from one package to another, help with different types of complex analysis. And of course, Bureau Happold was doing really complex projects. So there was a lot of geometry rationalization, that kind of stuff. So I had been working for them for a while, moved out to LA in about 2010, and was still working with Bureau Happold here in their Los Angeles office. And a piece of software that I had written called GoBIM, which was for the first generation iPhone. I don't know if many of you remember, but in 2007, the first generation iPhone, it was really like the first mobile device that was powerful enough to really look at sophisticated 3D models. So I'd written a piece of software to allow you to view BIM. You could export from Revit and view it on your iPhone. I sold that to a company called Vela Systems, which was a startup outside of Boston, who were building a field issue management application for the first generation iPad, which came online in about 2010, 2011, and made the jump full-time into software. So I went to work for them, worked on iOS and programming in Objective-C, and then they were quickly gobbled up by Autodesk, after about a year and a half after I joined the company. So that's how I got into Autodesk. And then the other project that I had started prior to that, which was Dynamo, the open source visual programming language for Revit. Once I was in Autodesk for about a year, they said, hey, do you want to turn that into a project inside Autodesk? And we'll support the open source, Dynamo effort, and we'll build a team around that. And had a great time over 5 or 6 years building that team and building that product inside Autodesk, which was really fun and incredible. And left in 2017 to start Hypar, which, as we talk about it more today, the more people learn about Hypar, the more they realize it's a sort of a continuation of all of these steps of research over time. It's a little bit of the mobile computing. It's in the BIM space. It's in the procedural modeling and parametric design space. And it's just a further continuation using, the kind of bleeding edge technologies that we have now. to do this kind of, what everybody is now calling generative design. So is that a good enough background?
Yeah, it's absolutely amazing. And so everything from artist, architect, engineering, software development, so a real true innovator with some artistic flair behind it. It's probably why your products are doing so well. Just for the listeners, would you try and explain Hypar in just sort of layman's language? What does it do? And
the very simplest way to explain it is that Hypar is a cloud system for generating buildings. That's a simplification, obviously. What it allows you to do is it allows you to, we like to say, externalize your expertise. So take the algorithms that represent your kind of expertise for generating building systems, whether you're an architect, an engineer, a contractor. You encapsulate those things in software. Individual sort of modules of software. You push them up to the Hypar platform, and then they are constructed in a way that they can all talk to each other. So, and then you can use our web application to go and actually generate building systems or generate buildings. And it relies on a lot of the technology of the modern web, and the way that the services communicate with each other. And the really interesting and novel thing about it is that those services communicate with each other with really well-defined contracts in the same way, and I'll explain contracts in a sec, in the same way that we do as humans in the construction or the design process. So as an example of this, if you're a structural engineer and you're working with the architect, you tell the architect, I need to know where the levels are in the building, and then I'm going to offset my structure from those levels, or I need to know where the edge of slab is in the building. And so the contract between the architect and the structural engineer is the architect says, okay, I'll give you some slab edges. And the structural engineer says, okay, from that, I'll generate some beams. Hypar works very similarly in that you define a thing called a slab edge. You define this concept called a slab edge. And then you define a system that takes in those slab edges and generates some beams. And so that is the thing that makes Hypar novel compared to all the other systems that we have out there. All the systems that we have out there right now are like based on modeling technology we've had for 40 or 50 years, right? It's like, here's a mechanical modeling application. Go model all your beams and columns and everything else. But those contracts are implicit, and we talk about them. And we try and manage models in that way. We try and say like, oh, the structural model is going to include this, but it's not going to include this. And we're going to merge it in via Revit, and we're going to visualize blah, blah, blah. And you can't move this and you can move this, but they're not explicit. And so Hypar makes a lot of those contracts explicit because they need to be explicit in order to communicate data between the services on the platform.
Fascinating. So it's like taking the building process and the outputs and almost putting it in like blocks of code, if you like. Yep. And then giving ownership of the various elements to the right people, so it's not the wrong person doing the job, and they continue, but it's feeding into a whole outcome, which is the building eventually. And there's two important things there. Like, one important thing is that the functions, what we call functions, the blocks of code, as you say, which is a great way to think about it. The functions are very small and purposeful. They should only do one thing, and they should do that one thing really well, and they should have a really well-defined contract. And then you have to think about the design of that contract and how other systems are going to consume that thing. And that makes it so that the contracts make it so that in Hypar, you might have a myriad of different systems that produce the same kind of stuff, and you can choose which system to plug in, and you can take one out and put one back in. So there might be multiple structural systems, for instance. One generates a concrete frame, one generates a steel brace frame, but they share the same contract. That is, I'm going to create beams and columns. So they're interchangeable in Hypar. You can swap them out. Basically what you're doing is you're unhooking everything, like all the processes that people would normally go through on desktop applications. And, let's put it this way, they're quite sort of heavy desktop applications because they've got every function that you might conceivably use as an architect or an engineer. So they're quite big programs, and it requires you to have sophisticated hardware, and you're connected basically to the desktop. Although there's ways to push that to the cloud, you're taking a lot of that and breaking all those functions down into mini functions, and putting those in the cloud so people are then connecting them up together.
That's exactly right. I mean, one of the challenges, and I always give this caveat at the beginning of podcasts. I love Revit. I built my career on Revit. Dynamo is successful because of Revit. So anything that I say, I don't want anybody to take it as like, I'm bashing on Revit in some way. But the challenge with a technology like Revit is you get in this place where you're like, well, I'm in Revit 10 hours a day. Like, I might as well have all my tools in Revit. And like you say, you're tied to the desktop. You are. And the challenge there is it makes it very hard for us to take advantage of some of the things that the cloud gives us. For instance, scalable compute. Hypar can scale up as much compute as it needs to do things like design option generation and optimization. It's super easy to take those little services and say, I need to calculate 10 different structural solutions. Spin me up 10 different services to compute those things in parallel. That's trivial to do in the cloud, but very difficult to do on the desktop with these sort of historical software.
Yeah, and limited hardware capabilities, etc. Yeah.
Yep.
It's kind of, if I thought of an analogy, it would, back if you went about 15 years ago, if you wanted to book a flight, the only people who had access to Skyscanner was the travel agents. So they had this fancy computer, and you had to queue outside the travel agents on a Saturday morning to get your chance to sit down with the travel agent and book your holiday. That's all in the cloud now, so everyone can sit at home without any sort of difficult hardware and make their own booking.
Imagine that and it's one of the things that I comment online. I'm taking a little bit of a Twitter pause right now, but when I was on Twitter complaining about these things, I look at all the brilliant work that architects are doing right now, for instance, using Rhino compute. So Rhino compute is the Rhino core that's been made into a web service which you can deploy on your own system and use as the back end to a front end application. And that's amazing. It's a cool extension of the Rhino technology. The real challenge, though, is that these historical technologies can't be made to scale in the same way that like microservices in the cloud can be made to scale. So Hypar from the beginning, we couldn't back it with Revit. We couldn't really back it with Rhino compute. We had to kind of build a lot of stuff from the ground up to fully take advantage of the scaling properties of the cloud. And the other point around this, like having Rhino or Revit in the back of this thing, is like, if you have a system that's based in those technologies, that's the buy-in to someone using that system. And there's huge parts of the world right now where if the buy-in to using the system is buy a license to Revit, they're never going to use that system. And the web and everything that we access on the web, what it tells us is that, everybody has a smartphone. Increasingly, everybody is going to have access to the internet. So if you give them access to things via their smartphone and the internet, you will win. And that's the other. So we're trying to reduce the buy-in as well. I don't want to say you have to go and buy Rhino plus Grasshopper in order to contribute something to our system and make something useful. I don't want to say you have to go and buy Revit and a computer that can run Revit to make something useful. We want to make the buy-in as low as possible.
And in terms of scalability, because I think that's a really interesting thing. If you are an architect or an engineer, then obviously you do have to perform a lot of functions, complicated tasks, etc. So you probably need a lot of these functions. Whereas if let's say you're a screed contractor, this might resonate with you, John. But all you really need to know is, as you said, the slab outline and the depth of the screed to calculate some volume. And that gives you the information that you need to be able to order enough materials to make up the screed, etc. So you could have so that person doesn't need the equivalent of Revit. They just need a small function that gives them what's relevant to their function.
That's a perfect example too, Ralph. I mean, there's so much in the tools that we have because we've had to put it in the tools on the desktop, like that's where everybody was doing their work. So we had to bake all the tools in there. And you need, as a specialty contractor or somebody who's doing a small portion of the design, you need a tiny little fraction of that capability. And so that's where Hypar is really neat, because some of the services align with exactly that. They align with a process boundary and give you only what you need. And the interesting thing is you could use Hypar. So we have this concept of workflows. We have functions, which are the blocks of capability. And then we have a workflow, which orchestrates those all together. So, as you pointed out, for an architect, you might have tens of different functions in a workflow that all together orchestrate and generate the thing you need. But you could also have an app on Hypar that has one function in it that just does the calculation that you just mentioned, or one function that just calculates the framing inside a wall. And that thing is now just a web application that you can access on your phone and use, right? Or on any device and use.
Yeah. Yeah. And what do you think about this? I mean, I think a lot of architects are kind of stuck in let's say, a state of limbo, if you like, where on the one hand, you are required through law and regulations and whatever to produce, let's call them old school types of information like drawings and schedules. And to get your building code, you have to submit certain drawings, and it's all built into the regulations. And then on the other hand, you want to produce these data-rich graphical models where everybody can collaborate. And so so something like Revit or ArchiCAD gives you the best of that, if you like. It gives you the ability to create the models, but also the ability to generate all the outputs that you might need under the various regulations. Like, where do you see that going in the future? That's not going to change quickly, because obviously you'd have to change the regulations and the law.
I don't harbor any delusions that is going to change anytime soon. But it is kind of funny. Like, our software has come to look like the industry, right? Our software, there's an old joke about married people, they come to look like each other after like a long time. Like, our software has come to look like the risk that we're all worried about shedding. It's come to look like the delivery, the documents that we have to deliver to the city, and so you're right. We're in this limbo where architects are feeling this excitement about all the technology that's out there, and they're imagining what they could do if they had model-based delivery and these kinds of things, but they're stuck having to deliver things the way they still do. So the way that this conversation is going around Hypar right now is we know that drawings aren't going to go away anytime soon. So what we're going to do, but at the same time, we don't want to turn Hypar into a drawing generation platform necessarily, because that's a very different and expensive problem to solve well. And Revit has solved that problem pretty well. Revit and ArchiCAD and others have solved that problem pretty well. So the position that we're taking is we're going to make it so that Hypar can generate huge amounts of like model data and make it super easy to change and iterate on and optimize, and then that thing should be compatible with those applications that you now use to cut your drawings, right? Mm-hmm. You should be able to generate models and do really lightweight design optioneering in Hypar, and then take that stuff and just put it in Revit and then do your set, your drawing set from there. Because we don't really, we want to use the tools that we have for what they're really good at. Revit is really good at making coordinated drawings. So we use Hypar to do generation of all this stuff in the cloud, use Revit. But having said that, we do have people who want to completely divorce themselves from Revit. We just had a conversation yesterday with a large self-perform contractor here in the United States who, and we have this conversation a lot, said, I want to get out of Revit. I don't think I need Revit in my pipeline. Here's what I need. What I need is drawings that come out of this process that are like some specialty drawing for my, my pour layout, my concrete pour layout, or my rebar layout, or whatever. There's tons of different types of drawings, shop drawings, fabrication drawings. And a lot of those could be automated on the back of the same systems that are in Hypar generating the 3D stuff could also be generating the 2D stuff. So they're trying to convince us, like, okay, you guys generate all this cool looking 3D stuff. We can visualize that in the browser. What would be super useful to us is if you could also just generate this simple shop drawing that represents this thing, because that's another place where Revit actually isn't great. So Revit's great for doing like architectural or structural building drawings, but it's not great for doing shop drawings, which are keyed to the sort of thing that's generated, but are oftentimes very automatable. Yeah. So there might be some drawing creation capability that comes online in Hypar in some form, but it'll probably be of that form.
So that industry's dragging you into the past, is it?
Well, I should say, drawing is a form of data compression, right? And it's a very useful form of data compression in a lot of different phases in the process of building a building. So I want to support those where it's useful and totally makes sense. But no, I don't see Hypar getting dragged fully into make my plans that have to go, my building plans that have to go to the city.
No, I was just joking. Sorry. John.
Just want to be clear.
Yeah, absolutely. So that's first. Actually, I had one last question, John, before we go on. Is you spoke about Revit doing what it does well and Hypar doing what it does well. Is there a connection between, like a live connection between the two, or is it you do your design work and once you've said, okay, that's the design, it's like let's bring it into Revit and then it's divorced basically from the Hypar? Or
well, so we did something really quite cool, and we haven't really shouted from the rooftops about it yet, because we're a small team and we have a lot of irons and a lot of different fires. So our Revit integration has two parts right now. One is a typical sort of import export. We've got what are called converters. Hypar at its core has this library called the Elements library, which is part of our open source stack, and it creates the elements, which are the things in a building: columns, beams, walls, windows, doors, that kind of stuff. We have a converter architecture where you, as a contributor of a different type of element to the system, can also provide a converter, which is a very simple interface to make calls to the Revit API to generate Revit stuff. So you can create both the element types and the converters, and that allows you to import, export stuff from Revit as real Revit elements.
Yeah.
And we have a pretty rich set of converters already to do that stuff. That's kind of typical. But when we started Hypar, we wanted to see if we could hook into Hypar Live so that you could actually see the entire context of a Hypar model in your Revit model, but allow you the flexibility and the speed of doing design in Hypar, but seeing it superimposed in a larger context of a Revit model. Yeah. So a few Revit cycles ago, they released an API that allows you to stream graphics directly into the graphics pipeline in Revit. And they did this because of some of their larger sort of integrations with things like Navisworks, where people wanted to stream in large models, but they didn't actually want them to be part of Revit. They didn't want them to be stored in the Revit file. So we made half of Hypar's integration is actually this thing that we call the hub. And the hub is actually actively watching a workflow in Hypar, watching for changes. And whenever those changes happen, it's streaming that visualization directly into Revit. And so what's really cool about this is that you can imagine, we always thought that one use case for Hypar would be Hypar's kind of like looking over your shoulder and calculating things when you change things in Revit. So imagine, anything that you would want to visualize but don't actually want to see in Revit. I made the example of concrete pour locations earlier, right? Imagine, or concrete pour phasing. Imagine as you're drawing in Revit, like you draw a slab or you draw a building, you're changing the shape of the building, you change the slabs. And in the cloud, this pour layout is being calculated for you because there's a Hypar workflow that's just watching. And then it's streaming the visualization of that back in superimposed on that slab. So now you have a piece of construction logic that is real time being superimposed even on an architectural design model. Imagine like bringing that kind of feedback from that far end of the process all the way back to the designer. And that's all possible, because Hypar is just doing this stuff in the cloud and it's emitting events whenever it updates. And the hub is catching those events and saying, okay, show me the visualization, and then streaming that into Revit. It's really cool, and we haven't even started. We've got a couple of demos. There's probably a couple of videos on our YouTube where you can see this. We haven't really even come up with a super compelling demo yet, but the tech is really neat.
That's a fascinating idea, because one of the challenges in the industry is sort of junior people don't have the expertise, but they tend to be the ones who are working around in the models. Yeah, and then it needs a senior person to come and as you say, look over their shoulder. Whereas what you're describing there, I was just envisaging a senior person could put their logic of how to, let's say you were optimizing the pores of the slab, embed their knowledge and logic into a function, and that could be guiding a junior person as to what's the best way to reconfigure the slab.
Yeah, so junior, we have discussions with a lot of, especially contractors here in the United States, who do have a very real concern about expertise aging out of the profession and not being able to backfill quickly enough and have those people trained up at the same level. So is technology a way to sort of externalize some of that expertise and make it available? So there's the expertise thing, the young to old generation thing, but there is also this idea of cross-domain transfer of knowledge. So the example that I was giving there is like, an architect just draws a slab on a page, but how that slab gets made and the ramifications of what design decisions are ultimately going to cost in terms of how that thing gets constructed are usually something that's meted out over emails and conversations and lawsuits and everything else later on in the process. What if you can pull a lot of that logic back upstream as well and give, construction information, just superimposed right there onto design time information as well.
Fascinating. John, sorry, I've been hogging the floor here, but it's just really interesting stuff. But I know John's on the same page as everyone. We're all looking for the future, the internet of construction and apps, mini services, microservices, and all these things. I'm sure you have some questions or comments.
Well, not as many as you, Ralph. But I suppose the main reason there is, for your interest is because you were an architect, and you can obviously, I'm sure when you see technology like this, it really has the potential to disrupt a workflow, like your way of working, and other architects and engineers, other design teams' ways of working, and it's really exciting to see Hypar come to the industry, because it's like a tidal wave in terms of the way that people are actually. I think it's the first tidal wave to hit design in a long time, in terms of really showing how an alternative and viable way to think about designing buildings as well. It really, it is really interesting. But it's, for me, I suppose my questions are, how do you see? Obviously, this is. This technology is very focused around, this 3D models, data in space, and the design stage of the building procurement process. I'm interested to know now what happens when it comes to construction and operations. Do you see because as you describe Hypar, and I'm sure other listeners as well, they'd be like, or for me, what it seems is that it's a centralized platform that can essentially replace Revit and BIM 360 in a way. Would you agree with that? To start with?
You're going to get me in trouble here, John. In trying to answer that question. Well, okay, let me tackle a couple bits of that. So on the construction side, we actually found, it's interesting in the life of the company, when Anthony and I started, Anthony Houck, my co-founder, and one of my colleagues when I was at Autodesk, when we started the company, we kind of bet that architects were not going to be our first customers, because there are things embedded in Hypar which are very challenging to architecture as a profession. The idea that you are going to embed your expertise, your authorship in this function, and then you're going to deploy it at a scale where, like, not only your entire team can use it, but also your entire organization and potentially the entire world, is so different to the concepts of authorship in architecture as they are right now, that we knew that this was going to be like a little bit of a big lift for architecture early on. And so we started having a lot of conversations in spaces which we knew didn't have this kind of existential hand-wringing. Real estate, that's all about the metrics, the financial metrics that drive the decisions about how to build the building, and also construction. So, in the United States and also in Europe and other places in the world, construction is becoming highly sophisticated in how it starts to use technology, and it's doing it in a couple different ways. There's the VDC way, which is virtual design construction, where they're starting to model everything, process modeling, 3D modeling. All of the collaboration that's done on site is now mediated through giant models that are federated together, and that whole process is driven by the contractors. And then all the other kinds of modeling, which I've mentioned here, there's 1,000 other problems that contractors are trying to solve. How do I do my concrete formwork? How do I do my temporary support structures? How do I do, we talk about these all the time, and they're just modeling those things by hand, just like architects are and everything else. So they found, wait, a lot of these things are algorithms. I have an algorithm that me as a contractor who's been doing this for 40 years, I know exactly how to deploy my materials on site and stage them, but that's a specific spatial problem. Like, I know kind of like how I'm going to place my cranes on site. Again, a spatial optimization problem, So they have hundreds, if not thousands, of these little problems that could each turn into a function. We just talked to somebody 2 days ago about crane placement. Crane placement is like a serious thing on a big job site, because cranes are hard to move around. You got to make sure that they're not in each other's way. You got to make sure that they can pick the things they need to pick and lift the amount of weight that they need to lift. And that's just something that can be embedded in a function and visualized, So contractors were a very early kind of interesting, and because neither Anthony nor I came out of construction, we didn't have any idea the number of really interesting and awesome challenges that they had that were so well aligned with the platform. So that's one. The other one that's very interesting is building product manufacturers. Building product manufacturers, that is the people who manufacture the stuff that goes inside the buildings. A lot of those building product manufacturers have to design their systems in order to make the sale of the system. But they only make the money on the sale of the system. So if you're Hilti and you make, for instance, all the hardware that hangs mechanical systems in the building. So if you look at a building and you look up at the slab and there's a mechanical system hanging there, all the Hilti components and stuff that's hanging there, that's what they make their money on, selling you the components. But that's a design system that has to be engineered for the for the weight, for seismic, for all this stuff. And they usually do that engineering at a loss because they want to make the sale on the hardware. But the engineering is based on algorithms. It's based on, okay, how many of these hanger brackets do I need at what spacing, so on and so forth. And that's all stuff you look up in a catalog right now. It's some PDF that's given to you by Hilti, if you're an engineer. And so automating that kind of stuff has a high value for them because it drives their design engineering costs down and gets them to that sale more quickly. So that's another one of these areas that we didn't know we were going to be in. And now we're having a lot of really awesome conversations to the point of like whether this replaces systems that exist out there. There is such inertia in our industry right now around several companies and several pieces of software that we're not naive enough to believe that we're just going to overcome that inertia as if by magic. What we imagine is going to happen is that Hypar is going to be an augmenting technology in its early days that's going to supercharge your workflows in those other applications. And like I said before, get you to a BIM more quickly than you can, for instance, in Revit. But then also allow you throughout that process of building your BIM in Revit to allow you to visualize these other kinds of processes that are being computed in the cloud. And then over time, if we're successful as a company and we play our cards right, we will take away larger and larger pieces of what those applications do now. And I think maybe, Ralph, you said earlier, the idea that we would dissolve those capabilities into just this fabric of services that are running in the cloud, and you can access as much of them whenever you need them at whatever scale you need them, and you can pay as you use that stuff. That's what will happen over time, is like it will just, the desktop applications that we use today will dissolve into this fabric of services that we use in the future.
Like apps on your phone. I mean, the app does one thing and that's all it does. But, you have a collection of apps that gets you through your day and does all the different things you need. But if you don't need all apps, you don't want to buy sort of a massive suite of apps that costs you, $5,000 a year, whatever, just if you need only 3 or 4 functions within that.
That's exactly right. And there's another interesting thing about that analogy. The analogy to apps or to services that are running in the cloud, they also pursue now integrations. So one app might say, oh, I really want to, it's a value to my customers to also be able to integrate with this other app. So that other app has an API. Let me just talk to that API. And John, I know this is something that you guys do with Bin Launcher, and you've done a lot of work with Node-RED and other kinds of ways of connecting systems in the cloud. That will happen here as well. You might just need that one little app that does a screed calculation like you were talking about earlier. But then you find, oh, I also need the thing that does the pour stop, design on the edge of slabs, whatever. And I want to connect those two things together. Let me just reach out to that service and call that API and allow these things to be orchestrated.
Yeah. And if someone has a bespoke function that, let's say they do build some of their expertise into a function, is there the opportunity to still protect that expertise but somehow share it without share
This was the question on day one. First customers of Hypar said, well, we're going to put our proprietary stuff in the cloud, and we want to run it through Hypar. How do we protect that? So we take pains to tell everybody the code that you publish on Hypar is yours and yours alone. We don't even see it, actually. We see a compiled binary that gets executed on our system. You can choose. We have really fine-grained access control, so you can choose to share that thing with your team, your whole organization, or you can make that thing public and share it with the world. But ultimately, that code lives with you. And also, there's a line between that and open source as well. You can also choose to make that code open source and make the code available for other people to tinker with if you want, but it's not a requirement of being on Hypar.
Yeah. And you recently gave a talk to the AIA and, just talking about the future of the profession. Obviously, that was the Institute of Architects in America. So you were talking about architects, and you made some really interesting points about, and coming back to scale, like we know architects are not involved in the majority of the built environment. I think it's something like 5% of buildings. It's a very low percentage of buildings actually involve architecture and good architecture, good urban planning, etc. And the rest is, just cobbled together by people who aren't trained in that profession. And so it's become almost an elitist service that certain people can afford, but the majority of people can't afford and can't access. And a lot of that is the cost of doing architecture because of the sort of slow and mundane processes that we go through, which is exactly what you're saying, I think, is that if you begin to capture some of that knowledge and let computers do what computers do well and let the humans do what the humans do well and combine the two, then you can deliver a much bigger scale of architecture to a much broader market, which is affordable. Is that a summary of your message?
Yeah, it's a pretty good summary. And the thing that was interesting about the AIA talk is that they, before that talk, they asked me to talk about equity and inclusion and diversity and all these things which are very important to the AIA as they pertain to their membership. But I kind of turned the question outward looking to the world. And I said, how can we talk about equity in the built environment if, to your point, so much of the built environment is never touched by an architect? And so let's look at that problem. Like, why is it? Well, and again, to your point, it's probably because architecture is a rich man's game. And why is that? Well, it's because every building from the beginning of time starts from scratch. I credit Anthony fully with this. When we first started Hypar, he had this deck that had a picture that was just like the Revit crosshairs, like the little section view indicators, like a blank page with just the section indicators on it, which was an upgrade of an earlier deck that he had, which just had the AutoCAD crosshairs on a completely blank screen. And he'd been talking about this for a really long time, this concept that like, why after thousands of years of building buildings is every building still start from nothing? Think about that. Like, how many stadiums has a company that builds stadiums and gets their next stadium project? How many stadiums have they probably done before? Hospitals, schools, whatever your specialization is as an architecture firm, you've probably done one or maybe many dozens of those before. Why are you starting from a blank page, laboriously building a BIM over months and months and months that then is like hard to change? Why don't you embed some of the logic for how your design process works into the tools that enable you to get to decision making faster? Because really you can't also get to making good decisions until you have enough sort of meat on the bone, to look at. And so the whole process is super expensive. We start from scratch. It takes us a long time to build the models. It takes us a long time to make decisions. We usually run out of time to make decisions. So you get a version of the thing that represents, whatever you had time to optioneer. And then on the next project, you start it all over again. And you also don't convey any of that expertise from one generation in your firm to the next generation of the firm, except by word of mouth, which was, for the many thousands of years, which is how humans communicated knowledge to each other. And then we started writing things down. And then we came up with computer software, which is a really good way to literally encode capabilities or knowledge in a system. And we got really good at using that in other industries, and we've just kind of been really bad at using it in AEC.
Yeah. I suppose while you were talking there, it's not as if every architect's starting from scratch, because obviously you have expertise and things. But I think the big problem there is the expertise is sitting in the head of somebody who's been through the stadium project, for instance. And so for the next project, that person then has to communicate what they know to somebody who's joined the team. So and often there's this tier of people, the junior people, as I said earlier, they might be fresh out of college, they don't really have any expertise, but they're doing a lot of the, let's call it the grunt work, if you like, making lots of mistakes because they don't have the expertise, but they have to make the mistakes in order to go and to show it to somebody high up the food chain to say, well, is that right? And then the person's going to say, no, that's not right. Actually, that doesn't work. And that it's at that point that the expertise gets shared, hopefully learned. I don't know. So it's very slow and cumbersome. And even like I used to work for a big architectural practice in Ireland, and so there were a number of teams, and even though people would obviously communicate and talk at lunchtime and whatever, the actual learning of each team, even within one company, hardly got shared amongst the teams. So you end up with a team that is the housing team and the healthcare team, and because they've had the expertise, but it hasn't been shared. So your idea of sort of capturing the knowledge in blocks of code, which then helps, well, firstly, it captures the knowledge in case, let's say somebody left the company. That would be disastrous if they spent 10 years with your company gaining expertise and then left your company. But also, it's that expertise is helping everybody else learn and do things faster, and not do it wrong first just to get it corrected, but try and do it right the first time.
So I also should caveat. I mean, there are firms that are probably amazing at knowledge capture and reuse and training and everything else. And I'm going to talk, way out over my skis, and people listening will probably say, like, this guy doesn't know what he's talking about. He hasn't worked in a firm like ours, which is really good about this. So I know that's out there. So for those firms, I say, okay, the other side of this problem is scale. The thing that everybody in the AIA is talking about is, how do we increase our market? Like, how do we, as a firm of 10, 15, 20, 50 people, how do we become a firm that can win bigger projects? How do we compete with bigger firms, And this idea that you, as a consulting engineer or architect, only has as much time in the day as you do to answer the phone or to write emails and be part of the design process, that is an inhibitor of scale. So what if you, instead of being a single individual, and this is a crazy idea, and this is why I say it's very challenging to architects, but what if all of the knowledge inside your architecture firm was externalized into a fleet of services that could be deployed so that somebody on the other side of the planet who you would not in a traditional capacity ever engage with has access to your expertise and can pay you for deploying that expertise on their project, mediated by technology, instead of mediated by the typical sort of structure of the consulting engagement.
So, John, what do you think? Is it getting towards your dream of the internet of construction?
Yeah, well, I'm interested to talk about hyperelements and the role that had to play with, I suppose, the success of your platform. Obviously, hyperelements, to my mind, is a common representation of common objects found in BIM models. And you have converters to and from different platforms, such as Revit. I mean, like, the success of hyperelements would depend on the adoption of hyperelements by more than just Hypar in terms of representation for a type of object. How is that going? I mean, yeah, I've seen a lot of activity around your engagement with IFC, but that was years ago. I mean, yeah, has frustration led to you kicking the bucket with that, or have you been like, no, you know what, IFC has its place. Let's create these hyperelements and have a converter to IFC that will tick that box? Or where do you stand with that now?
So when, John, when you and I first met maybe 3 years ago, I think it was probably predicated on some of the social media discourse that was happening at the time around IFC, because so just a little bit of history there. Autodesk gives people this sabbatical every 4 years. You're allowed to take a sabbatical for a month or something. So I was sitting on a beach in Hawaii thinking, if I were to start a company right now, what would be the tech stack that I would use to do the proto version of Hypar? And okay, I want to generate stuff for the built environment. I need some way of representing building elements. Okay, what's the industry standard out there? IFC. Okay, cool. Let's go find software libraries that allow me to build stuff in IFC. Wait a second. There's no really well supported, well documented, usable cross-platform, IFC toolkits out there that aren't some gargantumongous kind of thing. How is this a thing? How are we expected as software developers to build the next generation of tools for our industry? And the standard around which we're supposed to be sharing our data is, not only are there not great toolings for that in a lot of the different languages that we use on the web and in the cloud, JavaScript, for instance, being one of them. But also the API for that is incredibly difficult to use. And am I going to hand that over to Hypar users and say, now you have to learn IFC's way of structuring a BIM? So I was like, oh man, this is problematic. I think we need a better API. So Elements started from this idea of not wanting to replace IFC in any way. IFC was always seen as a compatibility mechanism into the applications that we use now that have IFC integration. Elements started as a way to provide a better API, a more usable way for somebody to create an element that goes in a building. So in Elements, you can just say, I want a new beam, and it has several parameters that you have to supply, and then that thing gets added to a model, and that's it. You don't have to know anything about references or relationships or any of the structures inside IFC. IFC very much came from a place of being designed by big software companies for use inside big software companies, inside the products inside those software companies. Since IFC's design, the whole software world has changed. Now, if your open source library isn't something that I can pull down via NPM in a one-liner and start using with a tiny little bit of documentation or example code, nobody's going to use it. So Elements was built with that in mind. It was like, what does a modern developer want to use? What do I want that experience to be? So one of the things that's core to, and the other thing that's core to Elements is its extensibility. So the other problem around something like IFC is IFC is a fixed sort of ontology of what should be in a building. Well, there's all kinds of stuff that's not represented in there. And every few years, the IFC committees get together and argue about what should be inside IFC. They're doing that right now with Rail. Okay, so the whole Rail industry wants to represent stuff via IFC. They're getting together and arguing like these Rail sweeps should be in there and these other kind of like equipment that are on Rail. Okay, in Elements, you just define a new schema in JSON schema for the thing that you want. Let's call it a slab edge pour stop. That's a thing. Let's make a slab edge pour stop thing, and its representation, its spatial representation is actually just like a flangey piece of metal that's extruded along some path that's provided in the constructor to that thing. And you create this element, and now it's a first-class citizen in the whole BIM. It's not some bolted-on thing. It looks and feels like everything else. It's a first-class citizen in the model. Now, Elements, the open source library, everything you create with that serializes to IFC, because that was always the idea, was that you should be able to take anything that you create via Elements, serialize it to IFC, and then use that import mechanism for ArchiCAD, Vectorworks, Tekla, you name it. That was your pathway to BIM. Now you might ask from that, well, why are you making Revit integrations then? Why don't you just use IFC? Well, the other problem with IFC is that in a lot of these contexts, it's been so underfunded in its integration inside some of these softwares that the integration is just kind of broken. And where it's not broken, it's not fully compliant because the spec sort of contradicts itself, or for a lot of different reasons. And Revit's a perfect example of this. People really want IFC to work really well inside Revit. And Autodesk actually wants it to work well as well. The problem is the IFC spec is so big and so heavy, it's been hard to implement it in a way that it actually works exactly the way you're going to expect it to work. So people have also said to us, I've done the IFC in Revit thing before. I don't really want that to be my path into Revit from Hypar. I want you to have a direct path that creates elements, Revit elements directly from Hypar elements. So sorry, that's a rambly explanation of where Elements came from.
Excellent.
So just to continue on with that question, just to confirm there that the Hypar elements, you said serialized to IFC, but that I assume that's another step. It's not the core object that's used within Hypar. So, for example, with this beam, you define it in JSON schema, and then that's in a function. You might, pass it to some sort of pass it to a function which generates an IFC compatible beam, or is it JSON schema representation of a beam? This is used throughout the Hypar platform, and then at any point, then it can be serialized to IFC.
So the way that it works is we say that Elements is schema first. If you want to add a new type to the system, you go and define a JSON schema. We have a bunch of code generation technology that will generate actual source code. We generate in C# right now, but in the future we'll support other languages as well. Generate the C# source code, and then you can use that in writing Hypar functions. But the data that gets passed around between services in Hypar is the Elements representation, which is usually the smallest. And we like to say that Elements should be the smallest amount of data that's needed to usefully convey that information from one process to another. So, for instance, a beam, if you're a structural engineer, a beam as you see it is just 2 points in space with a stiffness. And a cross section. That's it. You shouldn't have to convey more than that. So you might have a representation of a beam for you that's a structural beam that only encodes that information. So that's the kind of stuff that's getting passed around inside Hypar. only at the point at which you say export to IFC does any of that stuff get serialized out as IFC.
Fascinating. We're running out of time here, but I wanted to ask before a little bit about innovation, because AEC Hive is about encouraging people in the AEC sector to get into innovation, because like the general feeling is there's a low level of innovation, low level of R&D, etc. I mean, there's a lot of innovation and things happening at project level, but it's not an industry known for big investment into R&D, etc. Because you obviously at the cutting edge, you've been at the cutting edge through your work at Vera Happold, Vela Systems, of innovation. How would you say innovation actually happens? Like, is it just a spark of brilliance and some hard work, or is it quite deliberate and organized? Just if you're encouraging other people out there who have ideas and they want to pursue these ideas, and what's your view on how innovation functions?
Well, so first, thank you for suggesting that I've been on the sort of edge of innovation. To me, and maybe this is the answer to your question, it doesn't seem like innovation. It just seems like an evolution of things that I've worked on before. Hypar solves some of the fundamental problems that visual programming languages like Revit or like Dynamo on Revit and Grasshopper on Rhino cannot solve. And it's one of the reasons we had to make Hypar in the way that we did, and we had to build some things from scratch, was because that next stage in the evolution required us building that stuff in that way. We couldn't, Anthony and I and our CTO, Matt Campbell, all come from Autodesk. The two of them were on Revit. They were on the Revit core team. Like, they built a lot of the Revit technology. So we could have just built an add-on to Revit. Probably would have gotten us a lot more users a lot more quickly. There's 1 million Revit users sitting out there. We could have just and that was the success of Dynamo, right? You build it on top of Revit. You can piggyback on that success. But sometimes in evolution, there needs to be a bigger step. There needs to be a bigger investment in change. And to us, being on the web, being in the cloud, having a large part of what we're doing being open source was super important to providing the platform for that next generation of evolution. So we had to invest a lot to do that. So to everybody out there who's thinking about innovation, I would say, we're at a point in this industry now where innovation might look like, I'm going to build a Rhino compute backed thing with a web application for viewing my Rhino models and everything else. And I see 10,000 of these every day. Unfortunately, that's not innovation. Unfortunately, the next steps in innovation in our industry are going to take a lot of energy and capital to do. And the people who decide to do that are going to be up against that inertia that I talked about earlier. Prepare yourself for a slog. Prepare yourself to fight the good fight for a number of years, because removing people from these entrenched workflows that they have now, buying any mind share at all to get people to try your tool after they've spent 10 hours a day trying to deliver drawings in Revit, because that's the industry as we know it. It's huge. We're gathering all these metrics on Hypar now, which we gather these metrics to measure our success against these hypotheses that we make about where the industry needs to go. And one of the interesting metrics is, there's a 50-50 split right now between people who try Hypar during the week and people who try it on the weekend. And what that tells me is that everybody's hair is on fire during the week. You're just trying to get your drawings out the door, right? So it's not until the weekend when you have an opportunity to sit down and say, I'm having coffee on a Sunday morning. Let me try that Hypar thing that I've been thinking about. And you have that moment to capitalize on that person's attention. And if you fail in that moment, you don't know when you're going to get that person's attention again. So that means that just for us, it's a long fight that we need to fight, but somebody needs to fight it. So that's the last thing I'd say to, if you're worried about taking that next step, somebody has to take that next step in our industry. And there's so much opportunity. It's a huge industry. There's so much opportunity. And I would say on behalf of Hypar, we just want to help provide the platform that allows a lot of people to take that next step without having to build a lot of that stuff themselves, right?
And that's probably what a lot of innovators are thinking is, I've got to start, I'm on my own, I've got to start from scratch. But I think what you're saying there is, in terms of the evolution, is you're always building on work that's gone before you. So there's been fantastic projects, I suppose, if you want to call them that, in the past years, things like Flux and Speckle and, so things are happening, and it's like you shouldn't actually start from scratch. You should try and see a group of companies that are kind of moving to the same vision of a connected industry and work with them rather than against them.
I will also say what we're doing with Hypar, I probably shouldn't say this. It's not brilliant. What we are doing is we are taking models from other industries like the software industry, where open source has exploded in the last 2 decades, where communication and collaboration on code has exploded in the last 2 decades, where the tooling for creating microservices and standing up these scalable infrastructure and everything else has exploded in the last 2 decades. And we are piggybacking on all of that. And we're just trying to take some of those models and start applying them to our industry and wrapping them in tooling that makes them palatable for our industry. So it's also just like, some of innovation is just synthesizing stuff that's happening in other industries into ours.
Absolutely. Fascinating and really inspiring talk. John, do you have any last questions or comments?
Many last questions, many last comments, no time, Ross. So, it was great to have you and great to catch up, and I wish you the best with Hypar, and who knows, we might be collaborating in the near future.
Yeah, happy to come on again and answer any more questions you might have, John.
Brilliant, Ian. Thanks.
Yeah, and we've created the ACI community platform, and it's basically a place for companies like Hypar and others to tell people what you're doing. So if you feel you want to have a rant about something or discuss something, feel free to put a post up there and see if we can get some engagement with people and continue to follow the great work you're doing with interest. So any last words of inspiration to the listeners?
Well, I don't know if it's last words of inspiration, but check us out, hypar.io. It's totally free to sign up, and we have a pretty gratuitous free tier. You can go and play with Hypar and do lots of executions, and please give us feedback. We have a Discord channel, Discord server now, where we communicate daily with the community of people, and of course you can find us on Twitter at HyparAEC as well. We love communicating with people who are using the platform, trying it out, and telling us what works, what doesn't work, what's broken, what could be better. Yeah.
Excellent. Well, from my side as well, I just want to say thank you very much for your time. It was a fascinating talk, and we could have gone on for much longer, I'm pretty sure, but we do appreciate your time, and I'm sure we'll speak again. So
thanks, guys. It was
thank
my
you very
pleasure.
much. Yeah.